Hello students. In previous class we have studied about the unit of rho, about conductance, difference between ohmic and non-ohmic, correct? So in today's class we will study about what are resistors. Okay children, in order to see the combination of resistors, first we should know what are resistors. So we should understand first what are resistors. So we talked about resistance in last few slides, correct? What is resistance? It is the property to resist the flow of current. It is the property to oppose the flow of current. And what are resistors? The resistors are the materials which resist the flow of current. Okay, there is a slight difference, children. So resistance is the property and resistor are the object. So see the difference. Resistance is the property and resistors are the objects. So clear the difference between resistance and resistor. So there are different types of resistors available. Okay, one is wire bond resistor and another carbon resistor. So here we have two types of resistors. Okay, children. So you'd able to see these kinds of resistors available, correct? They are very small bits of resistors, but when we put them in circuit, they try to resist flow of current. When we look at this resistor, you can see that it is a small, just see here, it's a very small resistor, but it opposes the flow of current too. Okay, so what is the magnitude of this such kind of resistors and how to find out such kind of resistors magnitude? Children, resistors that also we can calculate by looking at the color. So we can calculate the magnitude of these resistors with the help of these colors, but not in 10th standard class. You will study about this in your 11th standard class. Okay, so this year it is not necessary to understand how to find out the magnitude of such kind of resistors. Okay, so one more resistors you can find here. What is wire bond resistor? Wire bond resistors looks somewhat like this. Somewhat like this it looks. You can see here somewhat like this it looks. It is like some metal over which number of turns, you can see here the number of turns, wire turns are there. Yes, it is many wires are taken turn on this metal, and this is works as a one type of resistor to resist the flow of current. So these are the two types of resistors. So here also you can see I have shown the picture of resistance, and this is the circuit. We can represent this symbol in a circuit diagram. You can see here it is a variable resistance, or you can say rheostat, and in a circuit diagram you can represent like this way. And this is an instrument, or it is a device used to measure electrical resistance, that is ohm meter. How you have seen the ammeter to measure current, voltmeter to measure potential difference. Same way, here we can also measure electrical resistance with the help of ohm meter. Okay, children. So let us move to the next. Now you can see here combinations of resistors. when we design electric circuit, we often use resistors, correct? Why do we use resistors in a circuit? In order to prevent huge amount of current flow through the circuit, because it might spoil electrical elements, correct? How, ma'am, how would it may spoil electrical element? Children, most of you have electrical appliances at your home, correct? We can take one example like refrigerator. In your home, if you have a refrigerator and refrigerator wants certain electric current, not more, but instead of giving certain electric current, if the huge amount of current is flowing through the refrigerator may get damaged, correct? Yes, it will get damaged or no? Yes, it will get damaged. So to prevent that huge amount of current flow through the circuit, we use these resistors. Okay. Now, these are broadly two ways in which resistors are combined with each other. Which are those two broad ways? One is resistors in series and the other one is resistors in parallel. So these are the two types of combination of resistors. Okay, children. So now what is resistors in series? How we can define this? So what is the definition of resistors in series? When a number of resistors are joined end to end. When number of, see here, there are four numbers where number of resistors are joined end to end, so that the same current flows through each. Okay, the resistors are said to be connected in series. So have you understood the definition? When number of resistors are joined end to end, so that same current is flowing through each. The resistors are said to be in series. Here you can see this example I have given here. And when we show in a circuit diagram, we represent in this way. Correct? So children, let us take this example. I have drawn here for you circuit diagram of resistors. I have taken here R1, R2 and R3. I have taken three resistors here. Okay. And when we flow current from this end, now when the current flows from this end, it goes to R1, then same current will flows through R2, then again same current will flows through R3. Okay, so here in the entire circuit the current is same, but children, voltage is different in each resistors. In series, current will be same in all the resistance, but the voltage, that is potential difference, is different in each resistance. So what we can say, current through each resistance is same, but potential across each resistor is different. Okay, so these are the two important points you have to keep it in your mind. So now let us prove the mathematical expression for series, how we can get a mathematical expression. For that, you should know first mathematical expression of Ohm's law. What is the mathematical expression of Ohm's law? Just recall it. We have studied in the previous class, that is V is equals to IR. Okay, so if V is equals to IR, here we have taken different voltage, potential difference, V1, V2 and V3. So let me take here first V1. is equals to IR1. Why I have not taken I1 here? Because current is same in all the resistance. So I as it is R1. Okay. So the next one is V2. V2 is equals to current is same I R2. Then V3 equals to I R3. Yes. So these are the three things we have taken. Now take the equivalent values here. So V is equals to, we have taken 3 times potential difference. So V1 plus V2 plus V3. So what is V? What is the formula of Ohm's law? V is equals to IR. So substitute the value of V. That is I R equivalent. Why I have taken R equivalent here? Because there are 3 resistance value. So I R equivalent is equals to, what is the V1 value? V1 is, here we have taken IR1. So I have substituted here V2 IR2, V3 IR3. So just I have substituted the value here. V1 means IR1, V2 means IR2, V3 means IR3. Okay. So now I R equivalent, I will be common here because I is same in all 3 terms. So I we have taken common, I and I get cancelled. So what will be the answer? R equivalent is equals to R1 plus R2 plus R3. So here we got the mathematical expression for what? Series. So this will be the mathematical expression for series. So clear, children, about this series combination? Okay. Next we will move to the parallel resistance. So here also I have given one example. Here I have taken example, but before that we'll define what is resistance in parallel. Two or more, two or more resistors are said to be connected in parallel. Two or more resistors are said to be connected in parallel if the same potential difference, exists across the resistor. If the same potential difference exists across the resistance. So to understand this, let us see here. I have already drew here circuit diagram. So I have taken here R1, R2 and R3, 3 resistors I have taken. And when the current is flowing from this end, what's happening? The current is not flowing like this way directly. Now the current is divided in 3 parts. You can see this same current is flowing for R1 first, then it is flowing to R2 as well, and it is also flowing for R3. But the children, you can see there are only 2 ends here. There are not more than 2 ends. So potential difference is only one, that is V. But here now current is divided in 3 parts. Sure, understood? Okay. So current through each resistor is different here, but potential difference across each resistor is same. There is a difference, children. In series, we have observed that current is same in all resistors, but the potential difference was different in all resistors. But whereas in parallel, now current is different in all resistors, and the potential difference across each resistance is same. Okay, this is the difference between series and parallel. So now derive the mathematical expression for parallel as well. For this we need Ohm's law, that is V is equals to I R equivalent. Why we are taking equivalent? Because we are adding here resistors. So V is equals to IR is Ohm's law. Now we cannot take V is equals to V1 plus V2 plus V3 because here we don't have different potential difference, but we have different current. So we can take I is equals to I1 plus I2 plus I3. Okay, children. So now we need I. So I equals to, you can transpose this R equivalent to this side. So multiplication changes to division. So V divided by R equivalent. For I1 also same. I1 is equals to V will be same and divided by R1. I2 is V divided by R2 plus I3 is V divided by R3. So when we take V here and V common, V and V will get cancelled. So what is remaining here? 1 by R equivalent equals to 1 by R1 plus 1 by R2 plus 1 by R3. So here we got the mathematical expression for resistors in parallel. Children, whenever you need more resistance in any current, you have to use mathematical expression of series. And whenever you need low resistance in circuit, you have to use mathematical expression of parallel. They may ask you questions. Find out the maximum resistance. So which formula you have to use? When they say maximum resistance, you have to use series. Okay, because we are adding there. If they will give R1 is 10, R2 is 20, and R3 is 40. And they will ask you, what is the maximum resistance? Then you have to use series formula, because we know series formula is R equivalent is equals to R1. Here we have seen that R equivalent is equals to R1 plus R2 plus R3. For example, if they give R1 is 20, R2 is 30, and R3 is 40. So 40 plus 30 is 70 plus 20. So 90. So maximum resistance you got here 90. But if they will ask you the minimum resistance to find out in a circuit diagram, see here, if we take R1 is 20, here R2 is 30 and 40. So if you add this and if you get the LCM, you will get very less. Maybe you will get 6 ohms or something like that way when you divide it. So here the resistance you will get very low. So this is the difference you have to use. Clear? We'll find out the difference between resistance in series and parallel now. So you can see here the first difference is we have already got Rs is equals to R1 plus R2 plus R3, and resistance is in parallel is 1 by R equivalent or 1 by Rp. Rp means parallel. Okay, is equals to 1 by R1 plus 1 by R2 plus 1 by R3. The second difference is current I remains the same through all resistance. Okay, current is inversely proportional to each resistance. Inversely proportional means you can see here I1 plus I2 plus I3. It is when current is flowing through, it is divided into all three parts. So it is inversely proportional. Here again, we have observed V is equals to V1 plus V2 plus V3. That means voltage is inversely proportional to the resistance. Correct? And here V remains constant. We can draw a circuit diagram for series in this way, and in parallel we can draw in this way. So you can write these differences if they will ask you questions in exam. Find out the difference between the series and parallel. So you have to write this. Okay, children. So for today's class, we'll stop with this, and in the next class, we will continue with the heating effect of electric current. So listen, watch to this video and note down whatever I have explained. Okay.